The year is 1969. Apollo 11 is moments away from making history. The lunar module is just minutes from touching down on the moon. But just before landing, the computer goes haywire. Sudden chaos. Warning lights flash. Overloads. Confusion. 12:02 alarm. 12:01 alarm. No one in mission control knew what they meant, but one woman did. In that chaos, it was this woman's code that saved the mission because years earlier, she had written the right code for this situation. Her name? You've probably never heard it. But without her, Neil Armstrong never sets foot on the moon. Her name was Margaret Hamilton, a computer scientist, before computer scientist was even a real job title. In the 1960s, while most software was written by hand and most programmers were men, and women belonged in secretarial roles, Margaret led the software team at NASA's MIT Instrumentation Lab. And not just any team. She was the director of software engineering for the Apollo program. Her work? Writing the onboard software for the Apollo guidance computer, the tiny machine on board the command and lunar modules that would guide Apollo astronauts to the moon and back. She was meticulous, obsessively detailed. A woman writing code when the job title software engineer didn't even exist yet. In fact, she coined it herself. Born in 1936 in Indiana, Margaret Hamilton was a math-loving, logic-driven problem solver from a young age. She studied math and philosophy at Earlham College, but she didn't plan to work for NASA. She originally wanted to study abstract math at grad school. Then life happened. Her husband was studying in Boston, so she took a job at MIT to support the family. That job? Programming computers for weather prediction models and defense systems. She was writing mission-critical code before she even knew how critical it would become. When Kennedy declared the moon race, NASA had to invent everything from scratch. Rockets, capsules, guidance systems, and yes, the software to run them all. The Apollo guidance computer had just 64 kilobytes of memory. Not enough to store a single song. Margaret's job? To make sure it could perform dozens of critical tasks without crashing in real time. The stakes? Human lives, billions in funding, national pride, and failure was not an option. Every subroutine, every data pathway, every possible glitch had to be anticipated. Margaret didn't just write code. She engineered systems. Her team pioneered priority-based execution, meaning if the computer got overloaded, it would keep only the most important tasks running. If the radar system glitched out, the navigation stayed intact. If someone accidentally hit the wrong switch, her software could recover. She even simulated every possible fail scenario she could imagine, many of which NASA hadn't even considered. In one legendary case, her daughter accidentally hit a button that triggered pre-launch commands during a test. Margaret didn't scold her. She redesigned the software to handle the mistake. Let's fast forward to July 20th, 1969, the day of the moon landing. Her predictions came true. Apollo 11 is approaching the moon, but something is wrong. As it descended toward the surface, just minutes before landing, the guidance computer begins flashing alarms. 12:02, 12:01. No one is sure what they mean. The computer hit its limit. The control room is silent. Buzz Aldrin and Neil Armstrong are floating toward history, but the computer looks like it's about to crash. That's when Margaret's code kicks in. Here's what happened. The radar system, running in the background, started flooding the guidance computer with extra data. Unneeded, unnecessary, and unexpected. Any ordinary program would have choked. But Margaret had built something different. Her software was designed to prioritize tasks in real time. When it sensed the system was being overwhelmed, it ignored the unimportant tasks and focused on the landing sequence. The astronauts would have had to abort, but because of her code, it gave Neil and Buzz the green light. And minutes later, the Eagle has landed. So why isn't she in every textbook? Back on Earth, no one gave her credit. Neil Armstrong's boot print became iconic. Buzz Aldrin became a household name. Why don't kids learn her name alongside Armstrong and Aldrin? Because she wasn't in the spotlight. She wasn't on camera. She wasn't even allowed in mission control. At the time, Many still viewed women in programming as glorified typists, and their contributions buried beneath hardware headlines and astronaut fame, even though her software did what no one else could: keep a computer alive on the moon. Her name wasn't printed in history books, but her code was printed in 17 binders stacked taller than she was. Margaret went back to work the next day. Quietly, brilliantly, undeniably crucial. Margaret Hamilton was more than a coder. She was a pioneer, a systems thinker. She led one of the first large-scale software projects in history. Her team developed fault-tolerant code, the kind that could detect problems and recover in real time, something decades ahead of its time. She wasn't working with frameworks, APIs, or cloud platforms. She was writing logic in assembly language, testing on simulated hardware. And still, her code flew a spacecraft 238,000 miles away, landed it, and brought it home. She taught her daughter to play on punch cards. She worked nights and weekends at MIT. She literally wrote code that would travel 384,000 kilometers into space, with zero margin for error. Decades later, NASA finally honored her. In 2003, she received the NASA Exceptional Space Act Award. In 2016, President Barack Obama awarded her the Presidential Medal of Freedom. And in 2017, she was immortalized as a Lego figurine. But perhaps her greatest reward was proving this truth. A woman's logic saved mankind's greatest leap. Today, people call her a legend, the woman who made sure Apollo 11 didn't become Apollo. Mission failed. And she did it with code. Every space mission, every autonomous vehicle, every operating system owes something to her thinking. She didn't just build software. She built trust in computers when they were brand new. She made the machine human-aware. And when it mattered most, she made the machine save the mission. That's why Margaret Hamilton is not just a footnote in NASA history. You may never meet her. You may never need to write software that lands a spacecraft on the moon. But next time someone says tech is a man's world, tell them about Margaret Hamilton, the woman whose code saved Apollo 11 and changed the trajectory of spaceflight forever. Subscribe to the Innovator Vault, where the forgotten minds of technology finally get their spotlight.